What's up, pigeons? This is Bruce coming at you. We're going to be looking at some equivalent ratios and some strategies that you can use to find out whether ratios are equivalent. So let's just first start with your understanding of what an equivalent ratio is. So if we have a ratio of, let's use like a car for example, in 15 seconds, the car travels 60 centimeters. We could express that ratio a lot of different ways. We could express it 15 colon 60. We could express it 15 to 60, or we can express it 15 over 60. In order to be equivalent, well, we can move up, and then every 15 seconds, it would travel another 60 centimeters. So 30 seconds would be 120 centimeters. Another 15 seconds would be 45 seconds, and would be another 60 would be 180 centimeters. And they move constantly. So we could say 15 to 60 is equivalent to 30 to 120, or 45 to 180, and we could call these fraction forms too, and say 15/60 equals 30/120, or 45/180. You also know that within a ratio table or with fractions, you could go directly from something like 15 to 60, and if I asked you about 90, what if I wanted to increase that seconds to 90? You know we could also multiply 15 times 15, 30, 45, 60, 75, 90, 15 times 6 to get to 90, and 60 times 6 would have to work the same way, which would be, 360. Those would be equivalent. And if we were thinking about fractions, 15 over 90 would equal 60 over 360. And we would multiply going this way, times larger. So in this lesson, you are looking at finding out whether fractions are equivalent or not. There's 3 different strategies you can use, basically. A tape model. Not always the best strategy, but Common Core aligned. A table, or fractions. And let's go over this. So if you get a question that says something like, are 7 to 8 and 35 to 40 equivalent? How can you find that out? Well, there's a few different ways. Are they equal ratios? You could line them up in a T-chart and say 7 to 8. Is that the same thing as 35 to 40? Well, to go from 7 to 35, we're getting 5 times bigger. To go from 8 to 40, we're getting 5 times bigger. So they are increasing at the same rate. Therefore, we would say, yes, they are equivalent. The other way you could do it is you could look at a tape diagram. And in a tape diagram, it's a strategy that you need to know because you're going to see it sometimes, and you're going to have to be able to determine. So if it's a 7 to 8 ratio, 1, 2, 3, 4, 5, 6, 7, to 8, 2, 3, 4, 5, 6, 7, 8, and it's saying you're going from that 7 to 35, which would mean each piece of your tape diagram would have to equal 5. Does that hold true when we're moving up to this 35 to 40, when we're lining up that 8? Is that 8 in that same ratio to 40? Well, 40 and divided by 8, each piece would be 5. So you can see the rate of each unit, or the value, is the same. We're both making them a value of 5, so they are equivalent. Notice how when I made the arrows, that would be another strategy you could look at. To go from 7 to 35 times 5, 8 to 40 times 5, which this is the same strategy. Essentially, you could make equivalent fractions like this of 7 to 8 as a fraction, 7/8. Does that equal 35/40? And once again, times 5 times 5. They are equivalent because we're changing them by the same rate. Whatever you do to one side, you must do to the rest. Just to give you an example with another one, when we look at our 5 to 3, is that equivalent to say 30 to 21. Let's use our different strategies. We can start with a ratio table. 5 to 3, is that equivalent to 30 to 21? Well, to go from 5 to 30, we're increasing by 6 times. To go from 3 to 21, we're actually increasing by 7 times. So we would say, no, they are not equivalent. They are not changing at the same rate. If you were to do this or see this with a tape diagram, it would look something like this. Let me change my pen color. And it's saying is that 5 equivalent to, that's saying that 5 is equivalent to 30, which means each piece would have a value of 6, that 3 is equivalent to 21, then each piece would have a value of 7, which means they are not equivalent. Same thing, 5 to 3, to go to 30 to 21, times 7 times 6. Those are the strategies that you're going to be working on in this unit to evaluate whether different ratios are equivalent.